Well, hi, good morning. Thank you so much for joining me here in my shop. Today is February 7th. And what am I going to do with this radio now? So I've got it working. So now it's time to start trying to make improvements in it. I think I'm going to focus on the audio side of things first. And the first thing with the audio side of things is to check the output tube grid blocking capacitor. So, where is that output tube? The output tube is sitting, I think, right here. You can see a capacitor buried there. Maybe that's it. Let's look on the schematic and we'll identify the grid blocking capacitor. Okay, here's the schematic. I find this, I don't know what it is about this, but I find this schematic really hard to look at. Just looking at it is kind of has my eye going all over the place. Let's look over here, zoom in a bit. So we're looking at the output tube. Here it is. Here's the grid. There's the blocking capacitor, a small 0.006 microfarad capacitor. That could easily be the capacitor I pointed to. And what I'm looking for is some indication that they've shown, like this one here. This is a picofarad capacitor. I'm looking at the symbol they've used. It looks like it's the same symbol. So they haven't symbolized the tubular capacitors on here. So what's this guy doing? That's so important. So back here, this is the B plus coming up. It's a large resistor restricting the B plus going over to the triode of the detector tube, the triode half. And so there's a somewhat lower voltage here. You can see it's written right there, 85 volts, whereas you can see the voltage on the plate here, 250. So they really knocked it down to under 100 here, while it's 250 over here. I believe that has something to do with noise, but I'm not sure of that. That if you have a higher B plus here, you'll end up generating noise, which will then be amplified, and you'll hear it. I think that's the reason for the lower. You know, it could be, you know, accelerating the electrons off the cathode, accelerating them to too high in energy. It means when they strike the plate, they generate more secondary emission and stuff like that. And that's noise. I think that comes through as the hiss. I think. So only 85 volts pushing on it. It's not the full B plus pushing across here. But once these guys get older and they can they become conductive inside, some charge will make it through here and build up here. Now, why will it build up here? Because of this resistor. If this resistor were, 10,000 ohms or nothing, then any DC charge would just go away. It would go, a little hard to follow this, it would go here. What is all this? Okay, let's get away from that. But there is a resistor here, and so the charge has some trouble getting through here, and it builds up. And what are you building up? You're building up a positive voltage here. You're building up a positive charge here. That's not good. You want the grid to be negative. So a little leak here can cause the grid to go positive. And why is it going negative? What's forcing it negative? Maybe all of this stuff. If we studied it, we'll find out that this is a trick being used in the power supply to create a negative voltage. Don't know. I'm not going to study that right now. You may have to eventually. So to some degree, the charge, if it's leaking through here, has to overcome the negative pressure, if I can call it that, that's coming from somewhere else in the radio, some negative voltage here. But nevertheless, it can, or it can reduce the negativity of the grid. The end result is the steady state current flowing through here will get larger and larger. And the result of that is you wear out the cathode that much earlier. In the worst case, you can set these tubes on fire. Well, of course you can't set them on fire, but you can get it to the point where the plate is being struck by so many electrons firing through here because of the positive grid that you end up with a red hot plate. No, I've never seen that. Never been close to seeing that, I don't think. So what we want to do here is we want to get out the voltmeter, operate the radio, put the voltmeter on here, and read this voltage. Now, part of the problem here is the impedance of this part of the circuit is basically half. It's half a million. It's only 500,000. So I'll take back what I was going to say. I was going to say hooking up a meter here will bleed off the charge and give you a false reading on the voltmeter. But yeah, you will get a false reading even with a regular 10 megohm voltmeter, but it won't be much off. But I have 100 megohm input voltmeter here. I can stick on here, won't deplete the voltage here, and we'll get a look at it. And so maybe it's negative as it should be, or maybe it's not. We can always look for the proper negativity on this side of the resistor if we want. I think it would still be there. So you can see the proper bias or close to it here. See what's actually happening here. And that's what we're going to do. Okay, that's great. I'm going to do that. Now you have to bear in mind that sometimes when I'm making these explanations, I'm getting it wrong. I mean, I have only what's in my head to offer. And I'm not suggesting for a minute that everything in my head is correct. That's not the case. I already know that. But I think I got this story pretty good. Oh, one thing I didn't do is I didn't identify the I didn't identify which pin. It's kind of buried down in here too. Plus everything's gone kind of blackish in there. So we need to know the pin number on the output tube. What was the output tube? Who can remember the output tube? 7. What was it? It was. I'm cheating. I'm peeking at the schematic. 7C5. Right. That's right. 7C5. Okay. Let's take a look. 7C. C5 shows the grid on pin number 6. Okay. Pin on grid number 6. Now, counting these pins is tricky because the key is hard to spot. If the or maybe hard to spot. I'll just use this light here. There we go. So on these sockets, there's a negative terminal in the center that's contacting this the metal pin that's coming through the tube. Yes, I'm pointing at the wrong tube. That's okay. Not to worry about it. And I've noticed that the key is opposite this ground terminal. So the key is located here. So that's how we can start counting. Here, here, and what am I heading for? I'm heading for 5, right? 1, 2, 3, 4, 5. No, can't be. Can't be. The pin I just counted as 5 is grounded in every direction. So let's go the other way. So there's 8 pins here, right? 1, 2, 3, 4, 5, 6, 7, 8 pins. Trying to start with pin 8, 7, 6, 5. Same pin. All grounded. What am I doing here? Doing something stupid. Once again, I found a stupid thing. Hey, let's try that technique. What did it say? It said tip it towards one of the rivets until it pops. Wow, that's real easy to get out of there. Holy smokes. 7C5. Well, there's no doubt that's the output tube. 7C5. My pin counting has gone wrong. Let's look at the let's look at this with a closer camera. Now, as usual, the computer has flipped on the automatic focus, so this might not go well. Let's give it a try. Okay, here we go. see the key there. So this would be pin 1. Would it not? This would be 1, 2, 3, 4, 5. 5 is hooked up to this ground wire. Die. Everything's hooked up to that ground wire right there. What is going on? That's the tube. Yeah, the autofocus is not so good here. Here we go. That's why I never rely on it usually when I'm making these videos. Am I counting? I didn't count this. Let's try again. 1. Oh, maybe I'm starting wrong. 1, 2, 3, 4, 5. Let's just ground it. So am I starting wrong? This is number 1 down here. 1, 2, 3, 4, 5. This would be 5. Holy smokes, how am I ever going to sort this out? And there goes the focus again. I find the camera gets confused by patterns. If there's a pattern, I don't see any pattern in here, but so there's the capacitor I suspect is the one. It goes under this one. And you think that's the lead right there? Who knows? How can you tell? Oh, maybe I can see here. You know, I gotta fix the focus on this camera. It's just driving me batty. So we're gonna set it here. Come on, set there. And just bear with me one moment. You might say, Jim, why don't you do these things before you start the video, and then you don't make everybody wait for you to do these things? And the answer is, I don't remember. Okay, so it's fixed at this focus level now. Okay, let's go back and look at this. Okay, here, we're looking up. We're looking up under here. Okay, a little more light. So I'm trying to see the end coming out of that capacitor. I think I'm looking at it, and I think it comes. Can I move this? So I'm looking just straight with my eyes. Yeah, it really does. That really does look like the lead. Now I'll point to what I'm talking about, because you might be looking somewhere else. I'm looking at this lead right here. This one. Things are so short. I don't think I can move anything and see. Yeah, I'm not gonna be able to move anything here. It's done so short. Maybe I can move this capacitor a bit here. How about that? So you can see the end of the capacitor now fairly clearly. Right here. I'm pretty sure that's the lead coming out of it. And I'm touching and that lead comes over to this terminal. No doubt about it. Okay, so that capacitor is hooked up to this terminal, and that terminal, well, now we're getting a better look at the key in here. So it's pretty clear to me. Oh, for crying out loud. This is number 1 here. Sometimes there's numbers written right on these. So if this is number 1, this is number 2, this is number 3 that has the capacitor on it. 4, this makes this one 5. Not this grounded one. Okay, that's better. Where's this going? And there's more than one thing hooked up to it here. No, so much dirt. Wow, that's disappearing into it. So we're talking about this wire here. This red one here. Oh man, I don't. So how do you get a capacitor onto pin 3 of the output tube? Did I look at the pin thing wrong? What did I do here? Pin diagram wrong? 7C5 grid 1 is definitely on number 6. Did I say 5 all this time? 5 and 4 not connected. Maybe I'm looking for 5 when I should be looking for 6. So we could count back 8, 7, 6. Maybe that's what happened. Somehow I got 5 in my head. Okay, counting now. 8, 7, 6 puts us this one with a wire. Oh my god, disappearing down into all this schmozzle here. Oh my god, how am I ever going to follow all that? The only capacitor I can clearly see that's connected to the output tube is this one. It was on pin 3. So what's the deal with pin 3? 1, 2, 3. So 3 is this screen. Okay, let's look at the schematic. See, maybe I'm in the wrong ballpark completely or something. Let's look at the schematic here. Okay, so oh, what's going on? There's no 7C5. There's, so maybe they've shown it a little differently here. They're showing, instead of a grid here, they're showing this is like they're trying to indicate that this is a tube that shapes the electron flow. I can't think of the name of it now. Maybe that's shown as a grid on the other diagram. They're different. So here's 3, anyway, 3, and it's on the screen. And we're going to come down here, and oh my god, that looks like a connection there, that dot. And this thing just goes in every which way after that. Goes up. Yeah, you know, trying to, boy. I'm paralyzed here. Once again, paralyzed. So here's a capacitor off of pin 2. If I'm counting the pins wrong, then this is the capacitor I've seen. 0.004 could be tubular. like the one I saw. But this is the one I'm really after. So it's got to be on that wire I have not been able to trace anywhere yet. Pin 6. Does that look like a 6? That looks like a 5. That looks like a 6. Yeah. Okay. Let's go. Let's go to the big B. At the rate I'm going here, I'm going to get only one capacitor change today, but that's okay, as long as I can pull this off properly. One done correctly is a lot better than 3 with one done wrong. So we're going to use this meter. I'm going to try to read the voltages on the tube, and maybe that's going to add to the confusion. Maybe that's what it's going to do. So I'm going to start out with a high setting here. We know the plate on that is about 100 volts or less, so I'm on the 150 volt scale. If I hit the grid, I'll have to change that. Otherwise, we're not going to see anything. The grid voltage is going to be very low. Okay, we're plugged in. We're switched on. Volume's down. We have the antenna switched on, I think. Here we go. Again, the dim bulbs didn't come on at all, but I can see the heater on that tube. I should replace one of these light bulbs. Keep me aware of things. Okay, DC positive, 150 volts, grounded on the chassis. Let's go look at the supply voltage first. And that's going to be up here on this capacitor. So that's saying 75 volts. That's not very much. And that's saying, there we are. So that's over 150 there. So okay, so we know now I'm running the radio with restricted voltage, only 100 volts instead of 115. So everything's going to be a little low, but that doesn't matter. It's all kind of relative. So we're going to start here, right on the pin that I think is the grid. Let me get to it back this way. Okay, so you can hear it on the speaker. Once I break through the dirt, we need to make this much more sensitive. Now 5 volts, full scale, still positive up. We should expect it to go the wrong way. If this is a grid, it should go the other way. Going up. So we're reading a positive voltage, about 1 volt positive on this terminal. Now, there is no terminal on a tube that should read 1 volt positive. That shouldn't be happening. So we already have a good indication that the blocking capacitor is leaking and charge is building up on the grid. We also have good indication that's the grid because it didn't go up to 150 volts, so it's not the plate or screen or something like that. And when I touch it, you can hear some static come out of the speaker. So that's all indicating. Now, didn't I have this tuned to CHU Canada last time? Maybe I changed the band or something. Just thought I'd listen for a moment. Nothing there to hear. Okay, so far what this indicates is the grid has gone positive, and this capacitor has to be found and changed out. Now I'm going to test the rest of the pins here. So we're going to go back up to 150 volts. Plate voltage should be, I'll put this on the 500 volt scale, 250 right in the middle. Which one was that I was touching? This one here. So 200 volts, and I'm running the radio on reduced voltage. So that would probably get to 250. Why don't we find out? Let's find out. Up to 250. Ooh, what's happening there? That's not me. What was that? let's go back down. Okay, so plate voltage fine. Grid appears to be, oh, that would be interesting. Let's do the grid on full voltage too, just see what happens here. So I've got to go back down. 5, we'll repeat the low supply reading. Okay, so we're 1.2. Let me see if I can keep that on there. And can I do this? Oh, I don't want to do that. Touching too many things at once. Don't want to touch too many things at once. Back on here. And it's actually gotten less. Interesting. It's gone down to 1. Now that's kind of counterintuitive, but it is what it is. Okay. Let's look at the voltage on this capacitor, which I've never done. Now would be a good time to do it. So 500 volts full scale. This capacitor, which I did not look at carefully before turning the radio on. Shame on me. Come on. That was an exciting moment. Capacitor works. We know that. It's holding a charge. What exactly did I short it against? Ooh, I have a nice smell of ozone in here. That was a good blast. The problem is I have to look away at the meter. That's the moment of disaster here. Come on, will you just get up to 200 volts? Now, okay, my sinuses got cleared on that. So going back now to the grid, I have to trace that wire that comes off of there up into here. We're certainly not going to do it with the radio operating, that's for sure. Especially with this guy. He's going to come after me. Let's see. Is it holding a... No, it's already down to nothingness. Okay, high power lights and careful tracing, and I'm going to do that on my own, and we'll see if I can identify positively which capacitor it is, which appears to be a leaky guy. Okay, I managed to trace the wire using my super mega light here. Thank you once again for the viewer who sent me this blaster of a light. And what I was able to see with this powerful X-ray beam here, I was able to follow the wire around the back, around, it comes up here, attaches to this terminal. Attaches to this terminal here. Let's put the regular light on it. And this terminal is connected to, voila, this capacitor that I've been moving out of the way. It is in turn connected over here, and that just looks like another pin on this tube. The value of this capacitor is 0.006. Wow, LB, that's exactly what I'm looking for, isn't it? So we're coming off the grid, around. Oh, what happened there? What just happened? I don't know. So, is there somebody else in here? Anybody in here? No, it's just me. Yeah, comes around up to this terminal. This terminal is connected to a wire, a resistor, and this capacitor. The capacitor goes over to here. Isn't this capacitor... No, it doesn't go to ground. Well, it's coming from the plate of this tube. That's what this would be. Plate of this tube, capacitor, plate resistor, capacitor carrying the signal over to the grid of the output tube. This has got to be the guy right here. So if I read the voltage here, we should get the same as what I was reading back there. And on this side should be the 85 volts. And this would be the leaky guy. This big square capacitor there. What am I doing? So we're going to turn on the radio. We're going to make these measurements again. Okay, meter's still left on. Setting is very
I set it at 150 to start for some reason. Fire up the radio. Pick better terms. We'll switch on the radio. I don't really want to fire it up. Okay. Give it a moment. Just look for the tube lighting up. Yep, no doubt about it. So we're going to start on the grid, measuring the grid voltage, which we found to be a little bit positive. So we're on the 5-volt scale, positive upscale. Head for that grid. There we are. Same voltage, 1 point, what's that, 1.2, 1.3. Same voltage should be here. There it is. Okay, so I managed to trace it correctly. This guy is blocking how much voltage? Should be about 85, probably reduced because I don't have the radio running full. And so we're on the 150 volt scale, so this is just below 80 volts. This guy can't even hold back 80 volts. Okay, I think we've done the job here. We've identified the capacitor. Surprising to me, it's one of these kind. Usually those are highly reliable mica capacitors, but maybe this isn't. This might be a box-shaped molded paper wax capacitor. I don't really know. So we're going to remove it from the circuit. Okay, and I'm going to, I have a way of making mistakes at this point. So I'm going to take it off this terminal. Which I'm going to mark with this clip lead. And then we're going to take it off this terminal here. And I'll leave a bit of wire on this side. Bit of dirty black wire. Okay, we'll put a clip in. There he is. So this is not a common looking capacitor. This one just looks a little bit different from many. Type D. T-O-B-E, Tobe, or Toby. .600 volts, and it only has a 100 volt duty. Well, sure. Oh, it's cracked. Oh, it's cracked right open. It's not exactly cracking along the seam, is it? Oh. And the crack is starting to extend right through it here. Feel like exacerbating that? I do. That almost sounded like a dirty word, didn't it? Okay, now we're going to go in there with this sharp implement. Need a sharper implement. Okay, Swedish fish knife coming out. Or maybe it's just a Nordic fish knife. Even that's kind of big when you see it on the... We're going in. I'm going to crack this guy open. I'm going to cut my fingers off. There we are. We have cracked it open. What do we hope to see here? Well, I don't know how it's made and what has happened to it. Let's see if I can pop the guts right out now. Pop the guts. Oh, yeah. Nope. Well, you can see first off that the connection that's made, I'm pretty sure I'm correct in saying this, the connection that's made inside the capacitor between the leads here, you see how they're, doesn't exactly look soldered there, does it? This is more like a clamp. And I believe what they're doing here is they have alternating sheets through here. I'm not sure, but I think it's what it is. Alternating sheets of tin or aluminum separated by paper. This is the paper here. It doesn't look very good, does it?
and one set of sheets sticks out this way, and the other set of sheets sticks out this way. You can see a bit of them right in here. And then what they do is they grab the ends that are sticking out with this, somehow clamp it, squeeze it, however they're making it, I don't know. And so this one contacts all the sheets, you know, the odd sheets, and this one contacts all the even sheets, something like that is going on. If we get this apart even further. So the paper here is a bit of a brown color. It looks like a paper bag color, a cheap paper bag. And the reason it's not nice and white like your paper you write on is because that paper, to be white, gets bleached. And the bleach can leave, you know, bleach is conductive. So bleach, you put bleach in the paper, you never get it out again. So this is unbleached paper, sometimes referred to as craft paper. Tried to break the back here. Let's just dig it right out. I mean, I don't think it's going to be of any value anymore, so let's just kind of destructively disintegrate this thing. Come on, fish knife, you can do it. It's not a fish. It's not a fish. There we go. It's really kind of stuck in there. Okay, so a certain amount of destruction taking place here. Don't think these were built to be taken apart. Because, you know, not every repair shop back in the 40s had a Swedish fish knife. So we'll pull this apart. You can see the tin foil, the foil. Let's just call it foil. The foil. How it was in this clamp. You can see the connection of the wire coming in too. It's not really soldered, right? It's just another pressure fit, like a rivet sort of thing, like they smash down the head of the wire to make a connection there. All pretty flimsy, really, isn't it? When you think about it, this is all just pressure contact, and any little bit of trouble, corrosion or anything, is gonna mess this up. Oh, came out the other one. Came out. Now let's just see where the contact is actually made. Right on the end here. Right where they've. Well, they probably have some, you know, technique for doing this that made their capacitors better than everybody else's. Peeling this open. So these are all the sheets here. Can I just pull them out? Ooh, I pulled something out. I just tore it. These are very, very thin, of course. Everything is thin here. There's some paper coming off. That's like that's like a cover piece. And this is the business area. There's a piece of paper. Paper coming off all over the place. There's paper wrapped around it. Many wraps of sort of outside paper here. Oh, there's the tin foil starting now. So you can imagine this being on a machine spinning with the paper and the tin foil being fed into the spinning part. The thing I find amazing, I've done this a couple times, is how much stuff there is inside here. When you see it on the bench there, all pulled out. Oh my gosh, how many times around am I gone? Getting pretty thin now. That's the end of the road there. Okay. Not much stuff. Okay, it's not that dramatic. Sorry, it's out of focus, but it's not that dramatic. Well, wasn't that fun? Fun and pleasure. So now we see all the different ways. It's obvious that these things can fail. They can lose connection very easily, or the connection become wonky, cracked case, going to let moisture in. Moisture is going to do bad things inside here. And that's really about it, eh? Loss of contact, which is how you get an open capacitor. Resistors aren't much different. Well, they're constructed differently, of course, but they have the same sort of problem of trying to make this lead contact the parts inside successfully. It's a challenging thing. Okay, well, that capacitor is definitely done for the day. So I'm going to put a 0.006 in here, and then we're going to measure that potential again and see if it's gone negative from the dangerous positive voltage that was there. Okay, new capacitor is soldered in. Look at how bright and shiny it is compared to the rest. See how that sticks to my pliers there? It's because these are actually made of steel. These are actually steel wires with some kind of plating on them. Make them look like something other than what they are. Okay, I think we're ready to try them again and repeat the test and see if we succeeded in making some kind of improvement here. Okay, so we're ready on the voltmeter. Plug them back in. Now, what would this do to the volume? That's an interesting question. I'm not sure it would affect the volume that much. I don't know, to be honest with you. Volume's down to start with, and I think we're ready. I think. Why am I being hesitant? I don't know. And my subconscious is sending out a signal. No. I was going to say, did I put the wrong capacitor in? No. Okay, power on. Forget my subconscious. It's pretty stupid anyway. The thing about your subconscious is that it's really fast and really powerful, but it's really stupid. Okay, that's why you need your conscious mind to keep guiding the ship, because the subconscious mind is going to lead you into some pretty disastrous stuff. Are we on? Okay, it's working. That's a good sign. Sounds the same, basically. Voltage on the high side of the capacitor. What happened there? It went negative. That's not the high side. This is the high side. Okay, that's good. Yeah, going negative. Oh, thumbs up. So on the high side, we've got 250 volts sitting here. On the other side, we have a negative voltage. So I'll flip this to negative, and I'll make that much more sensitive. 5 volts, full scale, negative. Right over. 15 volts, full scale. So you're looking at 6 volts. Negative 6 volts now. So we've gone from positive 1 to negative 6. Wow, I think that's a pat on the back, Jim. I think that's what that is. So we take a look here and we see this tube requires, I'm looking for the bias voltage. For curves, to refer to miniature type 6AQ5. 6, I don't really want curves, but 6A, what have I got here? 6AQ. QRST, QR, 6AQ5, didn't he say? Didn't I read? So here we are. We'll just look down here in the operation. Not in push-pull. Class A, AB, or push-pull. Grid number 2, grid number 2. Where's grid number 1? What's this section? The maximum ratings. I think this is maximum ratings. There won't be any maximum rating on the grid voltage, will there? Grid number 1 to plate.
Oh, this is something else. This is showing it's a capacitance between the elements. I'm not interested in that. Just tell me the grid voltage. Come on, man. Maximum circuit value, grid number 1, circuit resistance. No. Why can't I find this here? Why are they hiding it? They're hiding, you know why? Because they did it in these charts that we have to go to over here. Oh, look at all this writing here. Oh my gosh. So let's see if we can interpret this chart. Plate volts. Plate something, or grid number 2 milliamps. Well, that's not what I want. It's just over here. Grid number 1 milliamps. I'm not getting anywhere here. This is not working out for me. Yeah, I'm not going to be able to interpret this properly. Okay, it will remain a mystery, but I would say, let's look at it again. And we're going to give it the full supply voltage here. Don't slip. It went down last time. It's going up this time. -8. Oop. -9. Now, so -9 gives you room to feed a signal on the grid of 9 volts. 9 volts. So this is 0. This is -9. So you can do this. You can have a signal. Got that? that's my very terrible sine wave happening there. So the bigger the bias, the bigger the signal that can be fed to the grid. So if the bias gets very, very small, what happens is you turn the volume up. You overdrive the bias beyond the signal beyond the bias, and you start to draw current on the grid, and this starts causing distortion in the output. This is the hand signal for distortion. Okay, that's it for today. That's all I'm going to do. Isn't that enough? That's enough. While I was operating this radio, before changing that, the output tube was stressed with too much current flowing through it, almost certainly. This is causing a wearing out of the cathode at a faster rate than intended. And in these old radios, with a situation like this, that output tube is probably not going to last as long as you'd want. I don't know how long it would last. I don't know. But you know, that's what we're trying to do, right? We're trying to make these things last. So there we go. Okay, enough eulogizing on this whole topic. You guys have a great day. I'm going to have a great day here today. See ya.